The video you're watching right now is a combination of different techniques I've been experimenting over the past few months here on my YouTube channel. It brings together the results I made with Pointcloud data, Gaussian Splatting, all combined and animated inside Blender. So today I'm gonna walk you through every step I took to create this animation. I'll show you the full process and the Blender file, starting from how I captured the scans, what tools I used, how I brought everything together inside Blender, and lastly I will share with you how I managed to create the light trail effect around myself. Everything you see here is fully synchronizing on the beat, but if you want to check out the final version with music, you can head over to my Instagram page where I share the complete result. Before we move on, I just want to say that this video is split in multiple chapters, and if you want to skip through the chapters, feel free to, or if you want to follow along, that's absolutely fine. Cool. To create this project, I ended up using two separate scans. The first one was the environment scan, where I captured the entire bridge location using my 360 camera. If you're curious to see how that part was done, I made a dedicated video on my YouTube channel, link in the bio. The second scan was the character, which in this case was myself. For this particular scan, I used my own camera, Sony FX3, which gave me a superior quality compared to the 360 camera. That's why I decided to split the scans instead of doing everything in one go. Let's go! Inside Super Splat, I first imported the environment scan and then added the character on top. Since the character was the main element, I remove everything else from the scan and keep only the character. After that, I placed the character in a spot that felt right for the animation, and finally I exported both scans as two separate files and brought them into Blender. Here we are in Blender, and this is the file I used to export the entire animation. To import the PLY files into Blender, you can start with the default stand for PLY import add-on. This will bring the PLY file into Blender, but without the color attribute. There's another add-on called import PLY as vertices, which is supposed to allow you to import the color data for each individual point. In my case, I couldn't get the color values to come through correctly, so I decided to continue using the default stand for PLY option. I first imported the environment scan into Blender, followed by the character scan. Once both were in the scene, the next step was to position them correctly in the 3D space, as they initially came into the wrong orientation. So make sure you do this step first. In my case, I didn't do it, and it was a pain navigating the entire project in the wrong axis. Another aspect I had to do to improve the environment was to create a floor for the bridge and the ramp. The reason why I had to do this is because it was too much see-through, and sometimes the character felt like it's floating, so I had to add these two planes. Now let me walk you through the edits I made for the environment, starting with the bridge. If I select the bridge and go to the geometry nodes tab, you will see that I already have a few nodes set up here. The first thing I add is a mesh to points node. This converts the mesh into points and also gives me control over the size of each point. In my case, I'm using a value of 0.015. If you increase this value, you can clearly see the points getting bigger. So this is where you fine-tune the overall look of your point cloud. Next, I use the noise texture to start manipulating the points. This helps to break the mesh into a more organic movement. When you apply noise like this, the geometry tends to shift away from its original position. To fix that, I use a vector math node set to add with the values of -0.5. After that, I added another vector math node, this time set to multiply. When both of these nodes work together, the geometry stays in place instead of sliding around. To push the effect further, I then added a Voronoi texture and feed it into the noise texture. This gives me a more interesting breakup into the point movement. To be able to animate this, I created a group input called distortion scale and W, which allows me to easily drive the animation over time. Just keep in mind all these keyframes were made and synchronized based on the beat. To import an MP3 file, you simply go to the video editing tab. Once you're into the video editing, you can drag and drop the audio file, and when you hit play on your timeline, it should automatically work. These are the keyframes I use, and on the right you can see the exact values that were applied. Originally I wanted to change the geometry of the characters, but it didn't work quite well, so in the end I left it untouched. You can create camera animations directly inside Blender, but I'm not quite advanced enough to build this type of camera movement. What I did was to track an existing FBA video that I felt would match the setup and the direction I was going for, and then I used a 3D camera in this environment. Sometimes I surprise myself how smart I am. In my case, I used a video from Pexel because it had exactly the kind of dynamic camera movement I was looking for, and it fit the shot very well. The best part is that the tracking process was done automatically in the background without me having to manually track anything. If you want to learn how to track automatically like I did, I made a dedicated video on my YouTube channel, link in the bio. In Blender, I had to do the same edits on the camera. The length was not matching and the position, so I had to use an empty and parent the camera on it. We can see on the left the graph editor of the parent, and if I click on the camera you would see the camera animation. Now if I do a viewport animation, this is the results we're getting. Before we move on, I just want to say thank you for watching. If you enjoy this type of content, please don't forget to subscribe. Now back to the video. I think this is the most challenging part of the video. If I enable the light trails from the outliner and expand the section, you'll see that we are working with a Bezier curve and an empty. If you click on the Bezier curve and go to the geometry nodes, you'll notice there are quite a few nodes involved. The light trail idea was inspired by a tutorial from Ducky 3D on YouTube, link in the bio. If you want to recreate something similar, I highly recommend checking out his video. In geometry nodes tab, I started with the group input, which is where the geometry enters the node setup. Next, we have a geometry node which allows the geometry to evolve over time. Inside that, there's a set position node that introduces movement and start forming. If I disable the current bake and go back to the first frame and hit play, you will see that the trace simulation happening live. This continues over time, and in my case I left it to run until around frame 20. Once I was happy with the number and the density of the trails, I hit bake to lock everything in. Because I wanted the light trails to feel a bit more random and organic, I added a noise texture and plug it into the RGB curve node. This gives me more control of the variation and position. If I disable and enable these nodes, you can clearly see the difference. Right after that, I use a scale node to control the overall size of the trails, and a combine XYZ node so I can move the entire light trail setup if needed. If I want to further adjust the scale of the curve, I can do that again using this same node. At the end of the geometry node setup, there is a set material node which controls the color of light trail. If I jump into the shader editor, you will see a few important nodes there as well. The first one is the texture coordinate node, where I'm using the object output and referencing an empty. This empty basically controls how the light travels to the trail. For example, if I move the empty forward or backward, you will see the light starting earlier or later along the curve. This empty is also parenting to the camera animation, so as the camera moves, the empty moves along with it. If I open the graph editor, you can see that I've added a few keyframes to control exactly when the light animation starts and stops. This was set how the music was evolving. Back to the shader editor, next we have a mapping node which controls the direction of the light along the curve. Finally, I'm using the two color ramp nodes with similar colors. One is slightly brighter in front of the camera, while the other one in the background has a slightly different tone, which helps add depth and separation to the light trails. If I do a viewport animation render, the animation is going to look like this. If I enable the lights in the viewport, you will see that there are quite a few of them in the scene. Because the environment is large, I wanted to see as much as possible, so I placed lights around the building and along the bridge to have more details visible in the camera. At the beginning of the shot, I added 3 lights, each one pointing towards the building to help define the scene. Then across the bridge, I placed area lights on each individual pillar to make the structure more visible. Pretty much every pillar has its own light. The intensity for for these lights was set somewhere between 5 and 10, just enough to be visible in the final render. You might also have noticed a few spotlights here. I used those to add extra light on the character. I added a flicker effect to these lights to give the scene a bit more dramatic feel. If I go into the graph editor, you can see exactly what I mean. The light intensity is constantly flickering on and off, and you can achieve this by applying modifiers directly to the lights. In my case, I use a noise modifier combined with the stepper effect. To tie everything together, I added a large box around the entire scene and apply a principal volume material. This basically adds more atmosphere to the scene and makes it look more cinematic. When it comes to rendering, I only had two options, Cycles and Eevee, and to be honest, Cycles gave me quite a lot of trouble on this project, so I ended up using Eevee for the final results. The output resolution was a Full HD 1920 by 1080, and I've done it with 100 samples. I also created a few Gaussian Splatting render using the 3D.js plugin by Kiri engine, and I integrated those shots throughout the video to add a bit more visual variety. There is also a video on my channel where I'm using this tool. After the renders were completed, I brought the files into Premiere Pro and I did a bit of color correction. As I said, this is my first animation in Blender. I quite like the results how it's getting, and if you enjoy this type of content, don't forget to subscribe. It really helps me to create more educational content on my YouTube channel. Thank you so much and Happy New Year!